We are here with Dave Salt, AOCS engineer for the Integral mission. Thank you, Dave, for accepting my request for an interview.
My pleasure. Yeah.
So the main focus, as I was explaining, is to go through a little bit of your career, because you are one of the most experienced engineers I know here in ESOC. And that is also why I wanted to ask you a little bit your opinion about the space world in its entirety. So things you would like to be happening, things actually that are happening. How happy are you on how things are going in this industry or in this world? And discuss maybe some interesting technologies put out by some company, new, old. Let's see, like a general discussion on everything.
Okay, let's see how we get on then. So, as you said, I'm Dave Salt. I've been at ESOC for probably coming up to 25 years now. But prior to that, I started off as a child. I was born in 1955, so just prior to the dawn of the space age. Grew up, I was basically 13, 14 when Apollo 11 happened. So I was very interested in space and space type things, space fiction, space super duper future bright things. Since I was a kid, I was growing up in a very, what I think was a very dynamic age in the 60s, my formative years. And then eventually I went to university, Queen Mary College London, did a degree in astrophysics, physics. Realised then my maths wasn't good enough to become a proper astrophysicist. I also realised I was more into the engineering side of things. I enjoyed that, more the practical. So after a few hits and misses, I eventually ended up, after graduation, at Rolls-Royce in Derby in England, working on gas turbine propulsion. So getting towards my goal of rocket propulsion. Aircraft and things. I was there up until 1986. Just prior to that, I'd spent a year in Cincinnati working for General Electric, which was another eye-opener as to how different, the same job can be done slightly differently by different groups. And then in 86, I joined British Aerospace. In their space, it was their satellite system, it was launch systems integration and system safety. They basically opened up a group because they were going to fly, they'd already been flying satellites off things like Ariane, Thor, but they wanted to fly one off the shuttle. In fact, they got two lined up to go off the shuttle. This was Skynet 4 and the Inmarsat 2. And these were due to go up on the shuttle, which unfortunately they never got to fly because of Challenger. But after that, I was then fortunate to join the group that were developing the HOTOL concept, which you probably remember from the history books, was a single stage to orbit, air-breathing, horizontal takeoff, horizontal landing system that was going to be able to do all sorts of wonderful things, fly like an airplane, get people into orbit, come back, turn around and do it again, hundreds and hundreds of times, and bring down costs and open space to everybody.
Did it have a kind of a rudder on the nose rather than on?
There was a canard at the front. There was various designs. There was the fin was on the back. And then it was we also put it on the front. It depended on the...
Just a sec. Let me move this here so you can...
Yeah. There was several iterations on the design, but the main thing was it took off on a sled, a rocket-propelled sled, which meant it wasn't quite single stage to orbit. But it was interesting, and I learnt a lot on that because my mentor... as I'd like to think of him, Dr. Bob Parkinson was involved in that. I also got involved with Alan Bond and the reaction engine people. And also some people at British Aerospace Wharton, which is in the north of England near Blackpool, who had been working on reusable launcher concepts back in the 1960s. And they in particular had worked on, the group I was working with on HOTOL had also worked on something called Mustard, which was a pure rocket concept. That turned out to be something of a bone of contention between the Wharton people and us, because they always said, oh, the air breathing is nice, but it's easier to do with a rocket. And we were saying the other way around, no, rockets have had their day, you need some new propulsion system. That, unfortunately, because of the way the money failed to turn up after we'd done the initial studies, the British government turned their back on it. And so after that, I just went on to do sort of future projects work at British Aerospace with ESA, looking at things like future space infrastructures, moon bases, Mars bases, European space stations. Great ideas people had in the mid to late 80s that Europe was going to take a grand leap forward. However, in 1992, it was clear that things weren't going our way, and also with British Aerospace, things started to have to slim down because of they were basically making people redundant because the company had quite big financial problems. And I got made redundant, but was immediately, through a friend of mine who'd left the same department a year or so earlier, got offered the job at ESOC, working on the space station, the Columbus module. So we were originally, the idea was that we would be the architects for the ground segments, so for Columbus and Hermes and Mantented Free Flyer and the Artemis satellites. So ESOC was going to be the grand central control center for all these great projects, which of course over the next few years withered and died, apart from Columbus, which then went through several, well, more than several iterations, and finally eventually got launched, as you know, in the turn of the century. But before that, I then decided that I just didn't feel I was doing anything really good working on that project. I lost a lot of enthusiasm for space working on that project. It was a soul destroyer. And so I then went into sort of the mainstream work we do here at ESOC, which was the basic operation of satellites. So I got onto the Huygens project and the Smart One project, and eventually did stuff on METOP, and then Herschel Planck, and finally XMM Integral, which is where I am now. So I can't complain. I've seen quite a lot of the various things that people dreamed of doing, and more recently, in the last probably 20 years, the things that people are actually doing on a day-to-day basis. So, you know, I've had my head in the clouds, but I've also had my feet put firmly on the ground by a lot of things.
Which is quite understandable. Actually, I made this motto really mine. But the point, I couldn't help to notice how many things you were going through at the beginning of your career are kind of similar to what we see now happening in the market. There's a renewed interest in reusable concepts, from rockets to capsules. Air breathing engines against pure rocket engines. So history repeats itself, or is there anything really new now which brought back old ideas which are now, I don't know, refreshed with new technologies?
The answer to that is yes and no. In terms of technologies and ideas, there is nothing new under the sun. Alan Bond once said to me, Alan Bond was the father of the air breathing cycle for HOTOL, which was the RB545, which he then redesigned as the Sabre cycle for what transformed from HOTOL into Skylon, which is still trying to develop a working concept. But he also was the father of the Dade. He and Bob Parkinson were the sort of involved in the Daedalus study. You remember the Starship study of the British Interplanetary Society of the early 70s. And he worked on the nuclear pulse cycle for that. And basically, he said, when we were discussing this, yes, the best way, if people want to understand rocket technology, and understand what the future can hold, is you first have to learn how to do some archaeology, because there were so many concepts and ideas worked back in the 50s and particularly the 60s that are now essentially gathering dust, and people have literally forgot about them. Another guy I like to think of as sort of somebody that I've known quite a long time, and as a sort of a friend, is Jeff Greason, who set up X-Core. And he also came back with the same statement, that to be good and to know what you really need to know for future projects, the first thing you have to do is learn about what was done back in the 50s and the 60s in particular. There's libraries of information, tests and experiments, not just ideas, but real hard work that was done, developed, paid for, and then filed and forgotten about. And that's not just in the West, and particularly in Russia. They did so much research and development and shelved things. They've got warehouses full of articles, particularly rocket engines and things.
Which makes things even more sad if you think about the status of the Russian space industry nowadays.
Absolutely. You're right. It is sad. But having said that, I think to some degree a lot of this was inevitable. We can go into the reasons why I think that. But I also think it bodes well for the future, because what we're now seeing is probably the third or maybe the fourth iteration of the attempts to make us a spacefaring civilization. And the reason I'm encouraged with this iteration, this cycle, is that I think we have actually sparked the one thing that's been missing before, which is a real rationale, a business rationale for why people should spend money, or should I say invest money, in these technologies now, which has never really been there. People look back at the days of Apollo, and in fact, I was a child of Apollo. I grew up, as I say, I was sort of 13, 14 when Apollo 11 landed, and the year before that, was almost 50 years to the Stanley Kubrick's 2001: A Space Odyssey, and the vision which that put out, which wasn't just somebody's dream. It was actually based on hard projections from engineers who actually envisaged what the future might look like. And you could argue, if anything, from that perspective of the 60s, they were actually quite conservative. Obviously, things didn't turn out that way. But yeah, the reason we were all so keen and so excited about what was happening with Apollo is that we didn't appreciate what was driving Apollo. We all thought Kennedy was this great inspirational leader who was pushing us out into the solar system. Unfortunately, in the last 20 years, I've come to realize that Apollo was simply a vestige, a part of the Cold War. It was done for a specific reason, and that was to show, to put it bluntly, that capitalism trumped communism. Sorry, I shouldn't use that word, Trump, should I? Capitalism beats communism, is superior to both the American people and to the world. So this was a Cold War tool, and like all these Cold War efforts, huge amounts of money were put into it. But remember the purpose, and in fact Kennedy's statement was a very simple statement of mission. We want to put, a person on the moon. He said, man, put people on the moon, or put a person on the moon, land them there, and bring them back before the end of the decade. And that was it. That was the mission statement. So in fact, they actually did that. But what you then have to realize is that's it, mission accomplished. Why should they go on spending? And in fact, there's quite, in the records, there's actually records of Kennedy saying openly that he wasn't that interested in space, that all he wanted to do is use Apollo and get the result. And that was why money was put in, but that's also why money was cut off after it had succeeded. There was never, this project was driven by space cadets, von Braun and all the others, and everybody believed in this, but the real controller of the program was the guys with the purse strings, and they weren't space cadets. They were doing it for an entirely different reason. And when they turned those taps off, the whole program essentially wound down very rapidly. Of course, given the number of people employed in it, and given the fact that there was technology issues and maybe potential future things, they didn't kill it outright, but they morphed it, they watered it down into a program that was very much focused on smaller goals, on consolidation goals. Let's get into orbit. The shuttle was obviously the primary output of that.
So, what do you think about? Let me rephrase this. Would you say then the Apollo application program that von Braun had in mind at the end of the moon exploration phase of Apollo could have been a sustainable future, continuing investing on the line of the hardware and technology started with the Apollo moon program, or the shuttle was a better choice, at least at that time?
Okay. There was the working group, the space working group that was set up. Spiro Agnew was running it back in the late 60s. And they came out with a vision for post-Apollo, which in fact retired the Apollo hardware as rapidly as you could. And they foresaw reusability, the establishment of an infrastructure. And I think that's the key word. You have to think of space access as requiring infrastructure, transportation infrastructures, transportation nodes. And they put forward a grand program which involved the shuttle, bases in low Earth orbit, which would be, tens to maybe 100 people, nuclear powered, the Minerva-powered shuttle that would go to the moon and onto Mars. And also then the space station modules could be used as habitation modules for the transit phases, and also on the moon and on Mars. So this was all foreseen. This would have been sustainable on the basis that it would have been reusable. Problem is, it required a massive amount of upfront costs to develop this, and the justification for those upfront costs. Everybody thought, as I say, the space cadets thought, yes, it's a natural progression, because you look at the Apollo spending and you just continue that. The problem was, of course, Apollo spending was predicated on a different mission, so the sustainability of the Apollo spending was never really understood by the people who had the vision. So Apollo applications, as you say, was this bridging phase that von Braun had, and then Skylab was the initial part of that. Yes, it could have bridged till we got the shuttle, till we got the permanent space station. It would have been a great thing. But again, it required continued production of Saturn V's. It required continued production of the CSMs, the lunar modules and things like that, which required money. And the money was cut off, effectively. Apollo was ended in 66. And that was it. That was the peak spending, I think, 65, 66. And it was clear the Saturn V production line was mothballed. It was finally, I think, cancelled just before the lunar landing. I can't remember the exact the exact dates, but the Apollo program was basically on the way down before Apollo 11 landed. And the rationale for why they were doing that is clear, because it was never intended as a space program to develop space access. It was a space program to show off American technical prowess.
Mm-hmm. It was basically the peak, it's like when you run the 100 meters at the Olympics. You give everything you have in a very short, very fast run. The goal is to win the run, and that's it. You are not like running a marathon where you spare your energies and the target is very far in the future. So it's a completely different kind of mindset. And more important,
the event has been set up for individual races. This has not been set up for, say, a relay race, which you could, analogy of Apollo was a relay race. It handed over the baton to post-Apollo. This was not a relay race. It was simply a one-shot device to demonstrate certain political prowess and beat the Russians, which it succeeded spectacularly. I think the Russians took a real sort of a psychological body blow from that. We know that it forced them to rush their space program with the N-1 rocket and all sorts of things. and they had to make a quite a big pivot from their space program, was what they did in the 70s. And then they, unlike the West, decided, as far as I understand, that space would be used as an industrialization process and in exploitation. And that's where their developments for their shuttle, the Buran, and all the other things headed. And they, from what I've been told by people and reports I've read and seen, they were seriously, up until the mid-80s, looking to have space industrialization as their primary goal to supplement their economy. So yes, they wanted to, I think they wanted to launch Burans every week, hundreds of tons, with facilities in low Earth orbit, starting with lunettes to illuminate Siberia, big reflectors, to space stations and things that would do industrial processing.
This really sounds like sci-fi, though.
It does sound like sci-fi, but only in the last few years people have discovered these huge, huge buildings out in Siberia, or in the, Kazakhstan, I should say, where they've seen like 3 or 4 Burans shuttles and other versions of the Buran Energia, which would be cargo carrying. There is physical evidence that this is what they were doing. I think they even, maybe they only laid the concrete for it, but I think they had more than one Buran pad. I think there was something like a dozen, somebody told me. I could be wrong there, but certainly there's hard evidence. And in some of the papers they had, again, through Alan Bond, who in his spare time was a bit of a Kremlinologist, as they say, working for certain branches of the government, looking at their the various details they got and trying to project what the Russians were up to in the late 70s, early 80s. And this was certainly the story that I was told later, that there was good evidence that they were aiming for space industrialization.
There is one discussion always restarting and getting people to, let's say, able to inflammate people, because, again, thinking about what you said at the beginning, how much, in your opinion, in terms of what SpaceX is doing now, is in-house innovation or original ideas, and how much, in your opinion, has been transferred through NASA from old ideas and studies done in the 60s and the 70s? Because I ask this because there's a sort of dichotomy. Some people see Elon Musk like a sort of a hero, really able to revolutionize the field, because it's like, whatever he touches turns in gold. Mm-hmm. And some other people say, look, he's a very good engineer. He's also very good in marketing. So it's difficult to draw a line and say this is all coming from SpaceX studies and internal innovation, and this much is actually something upon which SpaceX started building, like sitting, as they say, sitting on the shoulders of a giant. Mm-hmm. For us, which of course are not working for SpaceX, just passionate people, we find it difficult to draw a line and try to not mythicize people and look at the facts more than personal biases and sympathies. Mm-hmm. What's your view on this? I'm really curious.
Well, I think standing on the shoulders of giants is an apt phrase there, because it's clear that SpaceX they have not invented the wheel. If anything, they've reinvented it based upon ideas that have been around for half a century. I mean, the Americans were, if you go and look again at the late 50s, early 60s, there was a reusable Atlas program going. Mm-hmm. There was lots of things in the 60s, plethora of reusable concepts. So the idea of usability, because of course people were basing the technology that they were developing rockets from aircraft. The idea is rockets as a disposable item are for military use. This is ammunition. If you want to then put it to civil use for a transportation concept, then you have to obviously think more along the lines of aircraft. So reusability is a bit of a no-brainer in terms of, especially when you understand the cost of building a rocket. Having said that, it sounds like a no-brainer. There's an awful lot. There's a few details in there which maybe we can go into later that mean it's not a simple no-brainer. And there's reasons why reusability hasn't been developed up until now. But yeah, SpaceX in terms of and Elon Musk, I think he's obviously a very clever person. He is also very good at marketing, and what they've done is very good. They have actually done, in terms of developing reusable technology, what people could have done probably 50 years ago, even certainly 20 years ago. And that's the issue, that they've taken old ideas and applied them in today's environment with the idea of being making profits eventually. And I think it's really difficult to say, okay, why now? Why is it only happening now? Why didn't it happen 20 years ago? And to me, it has less to do with technology and more to do with, again, who's paying for it. No bucks, no Buck Rogers. I think it was Tom Wolfe in The Right Stuff came out with that quote. I don't know if, that's who said that before, but it's certainly very, very true. It's all down to somebody providing money. These things you don't pull them out of thin air, and they are very expensive. And when you look at the analogy of aircraft, yes, we don't throw away aircraft, but also remember that aircraft cost an awful lot to develop. The latest, the A380 and things like that, it cost 10 billion to develop. Now, the only reason it's an economical success, although some people would argue that maybe it isn't, but the only reason that people committed to it is because they saw a real business case to make money on that investment. In the past, when you've looked at rockets, there is not really the market to make that money. There are markets for these rockets, and I'm sure there will be in the future, but those markets are virtual. The only real tangible way of making money with a rocket is to launch communication satellites, or launch something for people who are prepared to, pay for it in the military, in the government. So that's how rockets have been financed up until now. It's been limited by the market, which is also very limited in itself, which means that when you look at the business case for reusability, it doesn't make sense. In fact, the business case for new rockets doesn't really make sense, which is why we're still launching people into space on essentially the concept, the rocket design that put Sputnik up. Rocket design, rocket building types of rockets is not really evolved. It's evolved through military developments and the odd idea with quasi-commercial type things, which is government-based things like Ariane, which again is national security. That Ariane, in fact, was predicated on the fact that it was caused by the fact that the Americans refused to launch the French Symphony satellite back in the early 70s, and that was the last straw. The French wanted an independent means to access space, and so with the Diamat rocket and all that, they developed Ariane, which would then harmonized into a European project through the formation of ESA. But yeah, so back to your original question, is SpaceX, are they doing something unique? They could be the only ones. They're just exploiting existing technologies, existing ideas, but they now have somebody who has enough faith in eventually something happening in terms of markets and that they're prepared to put a lot of money in. And let's be frank, this is the other thing. SpaceX and Blue Origin are primarily financed by one person.
More than philanthropist.
So their idea of a business case and closing is not the idea that, say, the people at Orbital Sciences or ULA would have. They are doing their investment, let's say, partly because they do think maybe sometime 20 years they will make huge amounts of money. But I think for these two guys, it's more the philanthropic, my name will resonate down in history. So whereas the other guys, the ULA guys, the people in ANSPAS have to go to governments or to investors, shareholders, and justify this spend on something that's quite big. Even I think Musk said he spent $1 billion developing reusability for the Falcon. Jeff Bezos the other day said he anticipates spending $2.5 billion to develop his New Glenn. So this is big money. When you're the captain of the ship, when you have ultimate power to say yes or no, make it so, you can do a lot of things. When you have to report to a committee and justify it, you can't. And this is part of the reason why we haven't seen anybody go into the reusability realm before. So yeah, I think that's the thing. But back to your original question, no, I mean it's based on a lot of knowledge, and it's built onto, and it's now the right time where actually putting that into a real, actually executing as a real venture makes sense to certain people, particularly people with lots of money.
Mm-hmm. That's to be honest, this was starting to think a bit and discuss a bit more details about it. Was the main point of my question, because I don't like myths. I like facts, and I personally I think this is the best way to understand a phenomenon. Yeah, rather than following your instinct, you try to stick to the facts. And it is interesting to observe that one very important point is when you are the boss and you dictate what you want and you have the money to make it happen, compared to a board of people which represent stakeholders and you have to respond to. So the inertia in such kind of financial institutions or companies is very, very different compared to what Jeff Bezos and Elon Musk have to face every day. Actually, they are the cleverer guys and the guys with the larger pockets in the room when they have their meetings, I suppose. So that's, I think, quite interesting and quite true, as well.
Yeah. I think these things if you're a dictator, a benevolent dictator is the best way to rule mankind. Unfortunately, a benevolent dictator tends to change into a malevolent dictator. In theory, it's the best way to go, but in practice, for the long term, it's very, very, very unwise.
It doesn't work.
It doesn't work
according to the design.
Yeah.
So we discussed a bit about SpaceX. We discussed a bit, maybe not so much. If you have anything to share with us regarding the Blue Origin company and what do you think they are doing and their approach, which looks to me also very different. While SpaceX is more extrovert and they like to immediately state something, we will go to the moon in 6 weeks, and then it becomes 6 years, and then you start to get a bit upset. On the other side, you have a very, I wouldn't say secretive, but kind of a private person like Jeff Bezos seems to be. And the attitude of the company sort of reflects that, because they also put this motto gradatim ferociter, so slowly, but then, ferociously following their target. So what difference do you see between these two actors? And later on, if you want, we can plug in some smaller companies, some smaller experiences which you might be acquainted with. Not many people know.
But just before I go into that, one thing it's worth pointing out is there's an old joke about how to make a small fortune in the launch business, and that is obviously to start with a big one. And that the history is littered with people who have tried this. And the one that springs to mind most readily is a guy called Andrew Beale, who around the late 90s, early 2000s, his company ended in 2000. This was a guy, you can look his name up on the internet, Andrew Beale. He was a owner of Beale Bank. So he was, again, a very rich person, and he decided he wanted to build his own launch vehicle. And he built the world's biggest hydrogen peroxide kerosene rocket engine. And it was a monster. And he was going to use this to launch commercial satellites. He folded the venture around about 2000, and he even took a one-page ad. He took a page out in Space News saying that he was closing his business because of unfair competition from NASA. which was very controversial at the time. And I think, again, there was some truth in it, but I think he bailed out and just to make himself look like the victim, which he may have been, actually, I don't know. But the point I'm making is that Bezos and Musk are not the first billionaires to try this. And you can go back and see the various people who've tried this, from Kistler as well, who was another very wealthy person all the way back. So the difference between these people's mentalities, particularly Bezos and Musk, I find intriguing. I mean, they're both what you might the term space cadets. So in that way, they're identical. They're space cadets, but they have a different vision for the future. And this is why I personally tend to follow. I tend to support the Bezos vision of the future rather than Musk's. Musk has what appears to be a monomania with Mars. He wants to go and retire on Mars. That seems to be the one idea that drives him. At least that's what he says. Mm-hmm. In public, I don't know. In private, what that really is. But certainly the evidence to date would support that. Bezos, on the other hand, has a vision of, it's more philanthropic in the sense of he wants to help the whole of mankind. He appreciates that, as people have said from, again, probably since 50 years, we have a limited planet, we have limited resources here, finite resources. A lot, but still, it is finite. And ever since the Club of Rome in the late 60s, early 70s and all that, people have been predicting doom and gloom with population growth and demand for energy and resources and subsequent pollution, resulting pollution. They've been forecasting collapse of society. Now, fortunately, that hasn't happened. I'm personally of the belief that it won't happen. Certainly, I hope in my lifetime, which may not be very long, but who knows. But I believe in humanity's ability to develop solutions, to work a way out of a problem. That's not necessarily true, but that's my belief. And Bezos' belief is that people will require more resources, more energy, but the carrying capacity of the Earth is limited. It's a lot more than we think it is, but it's limited. And what he wants to do is open up the resources of space, which, to quote Heinlein, once you get into low Earth orbit, you're halfway to anywhere, and space effectively represents an infinite supply of resources. So, put it simply, what Bezos sees is using space to open up our closed system, and therefore the limits to growth. The famous book and sort of this was the thing from the Club of Rome. The limits to growth can be removed, for want of a better word, by putting. But this is the thing: not necessarily moving people out into space, but putting all our heavy industries, all our dirty industries, all our industries that tear up the earth and are gobbling up resources that can't be replaced, to put all those industries into space. And then human beings can occupy the earth as it was meant to be, as a sort of almost a Garden of Eden. We can put it back to the way it should be. Population growth could grow, but I think the latest thing from the World Health Organization shows that we'll probably peak at the end of the century at about 11 billion and then possibly drop, which in itself might be another problem for the future. But the Earth's carrying capacity at 11 billion could be quite, I think, easily supported by a civilization that has the resources of the solar system at its disposal. I mean, simple things like just having solar power. All our energy comes from solar power. There's, again, effectively infinite amount of solar power out there. We just have to gather it and feed it back to the Earth, which is a lot easier said than done. But people have been talking about this again since the 60s and 70s. Again, asteroid mining is a reflection of this. You could manufacture the goods rather than bring the raw goods down to the raw materials down to Earth. Why not manufacture all your smartphones and your TVs and your cars in space? and then drop everything down on Earth, you know. So the ideal vision would then be you look at your washing machine and it says manufactured on Space Station 5 or something. But so that's the vision. And I think I actually like that, because it doesn't necessarily require that we ourselves go out and colonize space. And this is where I used to think that was the future destiny of mankind. I'm a bit of an O'Neillian. I believe that if people are going to colonize space, they're not going to go on the surface of planets, because we just may not be able to live on the surface of planets as a species for a long time without drastically altering our genetics and makeup. If we want to live as humans, the best place to do that is in space colonies, where you generate 1G in a vast environment that's equivalent to the Earth. You've seen the illustrations, which are, again, it's a nice idea, but actually doing it's different. It's a big challenge, but it's one that I think is a tractable challenge, given that you have the resources in terms of power and materials. And in the next 100 years, we could actually start to see some of that go on. But whether we do that or not depends on your children, your grandchildren, your great-grandchildren. I'm not so sure, given other factors on Earth. I mean, singularity to me is the biggest one that says we may not actually be around for another 100 years because we may have, you know, gone into the Matrix or something. I don't know. This could happen. But what it means is, though, just looking at space as a way of offloading the Earth's environmental issues in terms of material and energy, I think this is practical. Engineering-wise, it's a no-brainer. We can do it. It just takes imagination, not imagination. It just takes engineering skill, a lot of people working really hard, and money. And that's where the big problem's always been. How do you get the money? And going back to what Bezos and Musk are doing, they're trying to get a virtuous circle going where the economics of doing business in exploiting space, sorry, I use the word exploitation, a bit politically controversial maybe, but that's what we're doing. We need to go out and exploit for the benefit of all mankind. And that's the other thing. This vision has the possibility that everybody, and I don't mean just in the Western world in particular, I mean the third world, can all be brought up to the standard that we're used to. And I don't see what there is to argue about that. You know, unless you're a sadistic, evil psychopath. I think most people in the world would agree to that. But it's a bit of a pipe dream at the moment.
Well, but still, investing in something which is able to uplift the standard of living of the whole humanity, which is at the moment very, very unfairly distributed, is in itself a good thing, I suppose. So I don't know whether astronautics can offer a major component of the answer to this kind of problems or this class of problems, but for certain, it's a better way than war, than completely destroying our planet, trying to squeeze the last bit out of it. So it's an interesting field. Plus, if there's a field in human history which was able to unite different people from different nations to work towards an ideal, I think that's astronautics by all means. But maybe, again, this is my personal bias. Maybe.
Yeah, I mean, the people who, politicians, people who want to grab power, usually for themselves, they always say it's for the benefit of all mankind. And I dare say there are some out there who do have these aspirations, but for a lot of them, it's just a way of feathering their own nests and things like that, which is probably a cynical view, but sorry, that's the way I see it. But if we can access all the resources of the potential resources out there for the benefit of mankind, then it takes away a lot of the reasons why people want to go to war. Mm-hmm. There'll always be people with ideological views, with religious views in particular. But again, I'm of the opinion that if people can be educated correctly to see the world as we think it is, at least the Western society thinks it is, and that there are other things, there are, the real world isn't, it can't be explained by religion. There are things religion has to be there for, the imponderables, but for the basic, everyday life, how do you cure diseases, how do you feed people, and how do you, keep people warm and healthy? these things are only that they're the province of science and engineering. They're not the province anymore of religion. So good education is another factor. I mean, astronautics will, I think, play a part, a significant part, but it's only one part. There's a whole societal change we're going to have to undergo. And in particular, we're wandering off the subject now, in particular the fact that when machines replace a lot of people's jobs, how do you keep a population? How do you, people's pride, that they're not just seen as leeches on society, that they are actually making a contribution. And this, again, is down to education and things like that. And I am of the firm belief that even though you don't think you're making a contribution, we can't all be a Bill Gates or an Elon Musk, but you always make your contribution in some way. Even if you're in a wheelchair, look at Stephen Hawking. In particular, and if it's only just to mix up the gene pool, the meme pool, that's all. It's all grist to the mill. So I guess I'm coming over as a bit of an optimist, but I do believe that we have a future. I'm not a sort of a pessimist. Yes, there are. Don't get me wrong. There's big dangers we can fall down, and potentially some nasty things that could wipe us out. But I think we're clever enough, and I think we'll be quick enough to spot those and nip them in the bud. And we have the tools almost at hand to remove an awful lot of those threats. And part of that tool is astronautics.
Yeah. So we were mentioning at the beginning of this last segment that apart from SpaceX and Blue Origin, which seems to be the biggest actors in the new industry, we always have the big ones. Yeah, now Boeing, Lockheed Martin, their joint ventures, blah blah blah. But what's out there, which is in your opinion interesting in terms of new, agile, small entrepreneurs trying to innovate in this field or do something different, something more, something the big beasts cannot do?
Okay, I guess the word that you're looking for there is new space, which has unfortunately been around for about 20, nearly 30 years.
Does such thing exist,
Does such a thing exist? As an absolute definition, no. But as a general approach, let's say, to again, and it's more to do with looking at space as a business venture, as something that you do in a constrained way, knowing that you can't just assume the government will give you billions and billions. It's something you have to essentially bootstrap yourself up to. That's been around for probably 20 years, and of course it raised its head in the public's vision, as it were, about probably 30 years ago, when there's a lot of new space companies were trying to develop, again, reusable launch vehicles to satisfy the market for constellations, like particularly Teledesic. Constellations like Teledesic caused a lot of ventures to be created. Kistler, Kelly Aerospace, Pioneer Rocket Plane, rotary rockets, and those were trying to build new launch vehicles, but small launch vehicles that could satisfy the launch requirements of these relatively small satellites for gigantic constellations, which, considering the constellations that somebody like Musk is talking about now, he's mentioned something like in total about 7,000 satellites. I think the Teledesic model was at its greatest was like 1,000 or so satellites, which then shrunk down to 288 before the venture itself disappeared. But that venture spawned the new space. I believe actually a lot of that venture was spawned, the things like the small satellites, big constellations of small satellites, was spawned out of SDI, the Strategic Defence Initiative, in particular the money that people put in to develop something called Brilliant Pebbles, which was envisaged as a constellation of, many hundreds, if not thousands of satellites and small satellites in low Earth orbit that would do a sort of a kamikaze death dive at any missile that was coming up to attack the United States. But the technologies they developed there for small bus construction, manufacturing satellites in the way you manufacture cars as opposed to crafted individual ventures, all those things was grist to the mill to spawn something like Teledesic and Iridium, which then spawned the small launcher, reusable launcher, New Space as we called it. It all failed because in particular Teledesic never happened. Iridium was a shining success for about 10 days, and then the 3 billion of investment, which a lot of it was from Arab money, was then eventually sold off in a fire sale for 10 million. Mm-hmm. So 3 billion was sold off as a 10 billion thing to Boeing, who then operated it, and is still operating it as a profit. And there's a Iridium 2 being launched now, as we know, from
by SpaceX.
Exactly. So these are cycles, but trying to extract, okay, what does all this mean? The idea of New Space is that you bootstrap yourself, but you have to have some piece of grit to grow the pearl round. And to me, the thing that really precipitates all this as a real entity is the markets. Going back to markets, that you have to have something, somebody wants to have that product. And really, the one thing I've learned over all these years is that if you really want to push space ventures forward, it's all very well knowing about the technology, which is really cool. And there's some really cool technology, maybe we can talk about it later, that people just aren't aware of that could be developed. If we want to go to Mars in a week, say, things like that. But ultimately, you have to have the money, the justification, the business case, for want of a better word, to actually do that. If you don't have that, it's no bucks, no Buck Rogers. You're sunk. And that's what's never happened. New Space hasn't caught on. It didn't catch on because the markets were never there. People have been dreaming about markets, and people have done studies. They can name you hundreds of markets, but they're all virtual. You can't go to a market analyst and say, right, show us your turnover of this product, which was made in space, because they'll say, well, we haven't got the data. If I want to set up a company that manufactures shirts or plastic buckets, as long as I can go to many people who will give me statistics on the real markets, what it takes to get into those markets, and that gives me an idea of what I've got to do to make a profit. But it needs real data to work on. With New Space, a lot of the data they were putting in was, you can build a business case, but it tends to be garbage in, garbage out. And that's why it never really took off. Mm-hmm. But now we are starting to see the first real piece of grit that we can build that pearl around. And these are, markets that may actually start to happen in the next 4 or 5 years, which will give people confidence to invest.
Speaking of which, how do you see Bigelow Aerospace and their inflatable modules combined with some of these new space cadets working, for example, stripping the government from the monopoly of laboratories in space? What I'm thinking, for example, is something like a private space station.
Yes.
Where for much less money than you would pay. Okay, I understand you don't directly pay to the government, but if you consider the cost of developing the ISS, why not start, or would you think it's possible that there's something going on between Bigelow Aerospace and they're developing technology of inflatable modules combined with the new space cadets like SpaceX and Blue Origin and any...
Yeah, this is all going to be part of the grist to a mill. What I should say, and make it clear, there is no one silver bullet, magic bullet. And in fact, I'm glad there isn't one magic bullet, because one market tends to be something that's here today and gone tomorrow. What we need is a raft of markets, hundreds of markets, different people doing different things in space, doing things that we can't imagine. And this is one of the failures of space cadets. We have our ideas of what we should be doing in space, but if you actually want to know what will be successful in space and what we should be doing in space, you should actually ask people who've got no interest in space whatsoever, people who are basically only driven by making money, people who've got a vision how I can exploit space. So, going back to this example of the business case, the thing about, if I wanted to open up a shirt manufacturing facility, because the first thing in a business case is you need the market, because there are no markets out there, it makes my ability to go out there and raise capital a lot easier. It gives it a basic sense of credibility. There is a market I can sell to, not one I have to cross my fingers and hope materializes. That helps people give confidence that there is a potential return on this. The other two things, because I always think of it as a business case as a three-legged stool. So you need the markets, you need the technology to do it. It has to be. You don't need unobtainium or anti-gravity. You have to have credible technology at the right level of maturity, and that's the other thing. So there's risk gone. And the third thing, which people always forget about, you need a team capable of actually delivering that venture. So people who know how to manage, who've had experience. And that, of course, in terms of commercial ventures in space, is what we don't have. We don't have people who are in the industry who've gone and made a profit and who can then go and sort of and form another company. We've never done that. Everybody that works in the space industry is primarily working for governments, directly or indirectly. Mm-hmm. So again, the necessity, the markets, and the skilled set of team members who can execute on the venture, those we're really in dire need of. The technology, we have it. That's the least of your worries. And that's why I say anybody that wants to actually make a leap forward in space, you'd be better, apart from knowing your history, you need to be a bit of a polymath and understand the markets and the people. And there's also another factor in there, which is, because it's space, the government, because you don't want to deliver your single stage to orbit vehicle and you're just about to launch the first customer, you've got customers lined up, and the guy from the FAA or the whoever comes along and slaps a notice and says, this isn't allowed. And a lot of people fall into that. So you need to have somebody who's a polymath. And I think Bezos and Musk and a few others are now getting to that appreciation. I mean, Musk in particular, he knows how to play the government line, not just in regulation, but also, with Tesla and the other things, his batteries. He gets $5 billion a year in not direct money, but in grants and other tax breaks. So this guy is really clever, and he knows the business side of it, the government regulation side of it. Yeah, you've got to be a polymath, and you've got to hit the whole thing simultaneously.
I wouldn't expect anything less, even from Jeff Bezos, which is another very successful businessman. I mean,
they know the markets, they know the politics as well, and they know a whole load of things, and they also know technology because they're very clever guys, and not necessarily as intimately in detail with the technology as they would have you think they are. I mean, Musk always says he's the sort of chief engineer or vehicle architect. I'm not so sure, beyond drawing stuff on a whiteboard and saying I want it to look like that shape. I don't know how much he actually gets his hands into the nitty-gritty of optimizing the landing algorithms, for instance, and things like that. I'm sure he's capable of doing it, but I just don't think he has the time to delve into it in that much detail.
Yeah, he hired many engineers, and
you get bright guys.
He's squeezing them properly. So
but that's the way you build a business.
Yeah.
You don't do everything yourself. You have to organize a team.
Absolutely.
Yeah.
So I would say we answered pretty much all the points I made, with the exception of the last one. So if you would be the benevolent dictator of all space things, if you could design the space development on a clean slate, in the light of your experience and all the things you have been seeing in the past and what you observe now, what would you do? What would you change? Would you do something radically different or not? I'm really curious.
Well, okay, if I was king of the world, or
King
had,
Dave,
or had a
was there ever a King Dave?
yes,
I don't
King
know.
David, I think.
Well, yes,
A long
but
way, but anyway,
Yeah.
if I had Bezos' billions, which
You
is,
wouldn't be here.
I think it's 78 at the last. Yeah, I wouldn't be here for a start. No, but I think, well, first and foremost, let me explain something about my philosophy on this, because I think it's important. I'm a great believer in Darwinian evolution, which means I think the idea of picking winners is just is doomed to failure, and in fact, trying to pick winners is ultimately it's almost, I think mathematically it's quite easy to prove that you're going to be wrong. You know, if there is one optimum path, and you choose at random because you don't know exactly where it's going, it's almost certain you'll pick the wrong one. So my belief is that let the markets, let the people, let everybody who's got bright ideas try, and let's see how successful they are. Because, yeah, we're celebrating the success of Musk and Bezos, but you don't know, they could be wiped out, you know. I don't know, Musk might get arrested, or he might have another divorce suit, or he might just have a bang on the head, you know. Who knows how these things are going. So, but I think more likely is that the way they're going forward won't necessarily be as successful as they believe, mainly because I have this feeling that they're predicating their success on taking over the commercial ComSat market. And I don't believe, I've yet to be convinced that the commercial ComSat market has enough elasticity in it to support an ever-growing launch rate. What I mean by elasticity is if they drop the price by 10%, that there will be a 10% increase in the market demand. If anything, there's good evidence to show that you can keep dropping the price and the market doesn't actually grow in size, which means from an economic perspective, you as a businessman, you drop your price, you sell the same amount of goods, which means you've dropped your profit.
Losing money, yeah.
Well, you're not necessarily losing money, but your profit's down to the point where, yeah, you drop it. And if the elasticity is not there, then you go out of business. However, I do believe that the elasticity, there is a trigger point, and it may be that they can reach this trigger point, which is maybe, 10 million for the equivalent of an Ariane 5 or a Falcon 9 on low Earth orbit. That may then trigger the elasticity of the ComSat market to suddenly go into another phase. I don't know. Nobody knows. But there's been a lot of speculation about this over the decades. However, the other thing then is new markets. And this is why, for my own personal belief, I think that the way to go is to try other things. And my own personal bent, as it were, is very small launch vehicles, small reusable launch vehicles. And I guess you've read some of the papers I've produced over the years where air-launched small launch vehicles, technically and from a business sense, would appear to offer a very good way forward. Won't go into details with it now, but that's my belief. So if I was king, if I had these billions, what I'd like to do is I'd spend it in the following directions. I would spend an awful lot on basic propulsion research, because going back to HOTOL and the air breathing, things like that, after being working for air breathing and being sold on it, I don't believe it's the way to propel rockets, because the fundamentals of the physics, the engineering is rockets are accelerators, aircraft are steady state in their mission, and aircraft and steady state is what air breathers do the best. If you try and make an air breather accelerate, as a lot of people have found when they've put air breathing engines on missiles, in fact, you have to have a rocket to get it up to speed, because it has to be multi-cycle, and you end up compounding the problem. The other thing is, if it's air breathing, it's by definition the thrust to weight ratio, power to weight ratio is extremely heavy because of the air-breathing equipment. So what you save on LOX tanks, you unfortunately inherit in the weight of the propulsion system. And therefore, if you have a single stage to orbit propulsion system, you carry that to orbit, which means by definition, every kilo of air breathing equipment is one less kilo of payload. Mm-hmm. So air breathing, from what I can tell, is it is useful in the architecture, but it's best to keep it subsonic and just to get the platform above the sensible atmosphere, which means you can use current aircraft. So the air breathing has its place, but it's not the panacea. But it has a leveraging effect that is very powerful to allow you to do fully reusable vehicles. So what would I spend my money on? I'd spend my money on rocket engines. I wouldn't spend it on air breathers. And the way I'd have that spend go is I would get people to invest in a program that could produce a rocket engine that could be fired for at least 100 times without any significant maintenance. And maybe before you need the sort of a basic overhaul. And the ultimate lifetimes of many thousands, if not tens of thousands of cycles. In other words, I'd make the rocket engine as reusable and as reliable as modern day jet engines. Nobody's working on that. Now, there are from Musk and from Bezos the statements that their engines, the Raptor in particular from SpaceX and the BE-4 from Musk, from Bezos it's the BE-4, and the Raptor from Musk. They have targets for reusability of something like, I think Musk himself said the other week, something like 10 flights before you look into it and do any maintenance, and then 100 flights total. But I personally think you need at least one order of magnitude better. So I put my money into a program of developing highly reusable rocket engines, because that's the one area that rockets haven't been developed. We're not going to squeeze out any more specific impulse performance. But one thing nobody's ever really attempted is to make them highly reliable, highly reusable, maintainable. So that's the one thing I'd push for. I think people are doing all right in terms of modules on orbit, so Bigelow and things like that. There's enough of that around there. But the other thing, if I had huge amounts of money, and it would be very controversial, I would put a lot of effort into research for advanced propulsion for deep space. So we could get to Mars in a week and then back in another week. And there are design concepts that have been around for, again, generations that have the potential to do that. And I'd really like to see that, because I think the one thing we don't want to do is get ourselves into low Earth orbit, be able to get to the moon, but basically have the industry and the capability to go further stymied by chemical propulsion. And I think it will be stymied by chemical propulsion, but if you can develop a system that can get you, basically, we're talking solar system vehicles, get you to Saturn in a couple of months and back, then you really are giving humankind the capability to open up the solar system. Chemical rockets are probably going to limit us to the local Earth-Moon system, and maybe a bit outside that. We can go to Saturn with chemical rockets and other things like that, but we're not going to do it in an industrial and profitable way. So yeah, I'd go for
smelling nukes.
Yeah, nuclear
power again.
Yeah, I mean,
this is the kind of technology we're talking about.
And in this technology was actually first developed as a concept, and then some small subscale demonstrators without nukes in the late 50s, early 60s as Project Orion. This is the pulse-detonated pulse nuclear propulsion. However, in the 50 years or more since that project wound up, there have come along a lot better designs, which don't need kiloton bombs. They actually need sort of sort of small bombs that are the equivalent of they're not big nukes and they're not weapons. And then that's the other thing. You wouldn't detonate a bomb. You'd actually have a controlled fission detonation by compressing pellets, let's say of plutonium or americium or something else, tiny pellets that are about the size of BB shot, with external compression through lasers or electron beams or other things like that. So these systems are not going to explode in space. You have to physically condition them to cause the chain reaction, and in a very, very, very small pulse as well. So these could not be considered by any means weapon systems. However, they would, I think, only be allowed to operate from something like a Earth-Moon Lagrange point somewhere in deep space. You wouldn't put them into low Earth orbit.
Yeah, you don't want them to return.
Well, no, they would be. In fact, this would give you single-stage capability for round trips to Mars and back.
No, clearly I was more thinking about pollution in case of...
well, their exhaust would be actinides from the fusion or from the fission process. I mean, fusion would be even better. But this would be out in space and deep space, and there's so much... People don't realize how much horrible stuff there is floating about in space. Oh, yes. Cosmic rays, radiation, plasmas. But the vehicles themselves wouldn't necessarily, because of the cycle, they wouldn't be hot. This was the failing of NERVA back in the late 60s, early 70s. NERVA got to the point where they could have actually, it was flight ready. But once you start a NERVA engine up, it was hot. And you had to dispose of it, or certainly it was a nasty thing. These vehicles wouldn't be necessarily radioactive after they'd finished. They could come back to a space station, in other words, and be reasonably benign, let's say. I don't know. I mean, there's a lot of work to be done, but somebody ought to be researching that. And as with a lot of other things, all the work, the majority of the work, the research was all done in the 50s and 60s, and some work in the 70s. Since the 80s, since the last 30 or 40 years, we as a society have not really developed anything new, astronautics-wise, which is really sad. I know people will say, oh, there's electric motors and things like that. Yeah, but electric motors were flying in the 60s as well. Go and look up CERT-1. That was a vehicle that flew off a Thor missile, and a Thor launcher, which turned into Delta historically. But this was electric propulsion has been out there for many, probably half a century. What we've done is perfect the techniques and use them and applied them on a more commercial basis. But in terms of new cycles, new propulsion systems, the other thing so there's rocket engines, highly reusable rocket engines. There's highly advanced deep space propulsion, and the third thing I'd like to spend money on is some wacky ideas like laser propulsion, because I believe that we could actually, with ground-based lasers, propel spacecraft into low Earth orbit very effectively. I don't believe in space elevator for various reasons. Technically it's doable, yeah, but I don't think it's pragmatic. It's not the right thing to do, because ground-based lasers could launch people quite happily into low Earth orbit at fractions of the cost, based upon, the propellant would be water and things like that, and all the power's on the ground. So you'd have single stage to orbit on things that effectively, like Victorian boilers, really low technology, that all the high tech's on the ground, which is where it should be. So there's your three things. What would I do? Rockets, improve conventional rockets, chemical rockets, develop it highly advanced deep space propulsion, and look into a few wacky things like laser propulsion for the next within 30 years.
Which was one of the latest ideas developed by Hawkins when he started or he co-founded this initiative. Unfortunately, I don't remember now the name. Where basically a small spacecraft.
Star Wisp. Star Wisp, is that the one?
The one basically.
Yeah, lasers. It would propel something
beams,
to.
Just sending photons to huge sails and sending small spacecrafts everywhere at 1/10 of the speed of light. So you could in principle reach the next solar system in
but
conceivable time.
That's something, again, like the Daedalus project for British Interplanetary Society ran in the early 70s. It was realised that to make that work, you have to have a spacefaring civilization that can quite easily reach the resources out to Jupiter. It's the same with the Star Wisp and things like that. You need significant amount of kit actually in orbit, in deep space, to do this. What I'm talking about is things that would be very near term, relatively speaking, developing within 10 to 20 years, which would then scale up and get the basic, the first leg of the transportation system halfway to anywhere. That could be implemented with things like laser propulsion. But yeah, I mean, there's lots of things out there, but eventually it comes back to this point. I don't know what's going to succeed. What I do know is if nobody does anything, we are guaranteed not to succeed.
Exactly.
So the more people doing lots of different things, crazy things, okay, you have to be careful when you say crazy things. There's the old adage of they laughed at Christopher Columbus, and the follow-on to that is, they also laughed at Bozo the Clown. So you have to be, again, considerate in what you put your money into and where your research goes. But I think there's a huge amount of opportunity to research with not necessarily billions, but just a reasonable amount of effort in small things that could have a big payoff in the future.
So we have to hope in a considerable number of startups trying to innovate and find the right thing, and in some Darwinian way, the best ideas should emerge from.
Yeah, and it's a window of opportunity as well. I mean, what might work tomorrow may not work today. So you shouldn't give up. I think there's Darwin doesn't say it's survival of the fittest. It's actually survival of those best adapted to the current environment.
Yes. Absolutely.
The environment changes, something else comes along. So, I think you've got to keep your eyes open and keep looking and trying to do these things. And I know NASA I think they do try, and in Europe we're not quite as adventurous, but I mean, I don't blame the governments for not doing this. I do blame them in some ways, but it's a natural consequence of their nature. They're not really into that sort of thing, and they shouldn't be, because they should be spending taxpayers' money on fixing health systems and national security and things like that. So,
maybe paying for that kind of research that
some of the research,
not affordable by small companies. So you do some basic research, governmentally funded, and then you open the results to all possible interested parts, and they pick up and develop on them.
The problem is they have a finite pot of money, and therefore they have to be selective. Therefore they have to second guess. It's the nature of the game. So I don't know. But as I say, we were talking about what I would do if I was king for a day, or
there's no government. If you are king for a day, you decide. Is it. So you are the government.
That's what I'd do. But that's just for posterity. Let's see how it goes. But I am back to the original sort of thing about where we're going and are they doing the right things. I think we are certainly starting to see. I mean, Bezos himself was claiming we're at the beginning of a golden age, and I do believe that there is a potential for that. There's also a potential for it falling to pieces, but who knows? But I do think that, as I said before, your children and your grandchildren and great-grandchildren have a lot to look forward to.
As your fellow Brits, the Monty Python said, you look to the bright side of life.
I'm always looking on the... Yes. Yeah, exactly.
It was on the cross.
I won't sing the verses, but you always look on the bright side of life. No, I mean, you have to. What's the alternative?
Oh no, I completely agree with you. You have to look for the future and a better progress. And I think we got so far, and we are not making so bad. There are ample margins of improvement, of course. Let's see what these two guys can do and what some emerging company can do. And let's hope to have some initiatives here in Europe as well, because we always look at the other side of the pond.
Exactly. And this is why I talk to people like yourself. As I said to you earlier, I'm not proud I'll talk to anybody, but I can. But I do believe that, that the reason I'm in this business, apart from the obvious thing of making sufficient money to keep my wife and children, at some level of decency and respectability, is that I do believe that, we can make a difference. And even if you are not, you're not featured on the cover of Space News or something like that, by simply talking and spreading ideas like this, maybe it makes a difference. Mm-hmm. So it won't be me that makes the difference, but maybe you can make suggestions to somebody who can make a difference in the future. So I don't know. That's why I say you have to be positive and look on the bright side. Yeah.
Great.
Mm-hmm.
I think we reached the end, and we have enough material for 3 or 4 episodes, which is great. Which is great. Is great because, as I said, we have no time limits. This is the beauty of podcasting. We will just not ask our listener to take the whole pill at once.
Yes.
But that's my job, to cut it up in digestible parts. And then this recording is going to be released fully in English, so that anybody which can follow the conversation in English will enjoy and go back and listen again and again to some parts. I think there are many interesting parts, a lot of food for brains, for thinking. So thank you very much, Dave, for your time and availability and kindness. It's been a pleasure.
Okay. Mutual. Yeah. Thank you very much. Ciao.